A very good afternoon, children. Today we are going to discuss about the second group elements in the periodic table. The second group elements are known as group 2A elements. What is their common name? Yes, they are known as alkaline earth metals, which are consist of beryllium, magnesium, calcium, strontium, barium and radium. These are the elements in the second group. Why they are known as alkaline earth metals? Any idea? Yes. While reacting with water, which will form alkalis, and they are alkaline in nature, that is bases, and they occurred in nature as earths. We can collect them from nature or earth. For example, they are exist if you take calcium, it exists in the form of calcium oxide and strontia, strontium oxide, barita, barium oxide. So later they discovered as calcium, barium, strontium and named as alkaline earth metals. We will see the existence of alkaline earth metals. These are the physical state of alkaline earth metals. If we take all alkaline earth metals, they are soft metals. This is the image of alkaline earth metals. And in alkali metals, we have seen the flame coloration. Similar to that, the alkaline earth metals also form color to the flame. For example, you can see calcium having brick red color, strontium having crimson red color and barium having apple green color. These are the flame coloration of alkali metals, whereas we have seen the color of alkali metals, lithium showing scarlet red, sodium showing yellow, potassium showing lilac blue color. So this flame test is an important test to identify alkali metals and alkaline earth metals.
If we check the electronic configuration of alkaline earth metals, you can see a general trend. Its last shell consists of 2 electrons in the valence shell. That is, for beryllium, the last electron enters to 2s2, magnesium 3s2, 4, calcium 4s2, like that it goes on. So its general electronic configuration is ns2. And the physical properties. As we know, all alkaline earth metals are metals. They are alkaline earth metals. And they exist in the grayish white color. And if you check the trend in atomic and ionic radii, as we move down the group, the atomic radii increases. Similar to this, ionic radii also increases. Why it is happening? Because moving down the group, the atomic size increases. We are measuring the atomic size in the basis of atomic radii. Why it is happening? Because the atomic radius increases because as we move down the group, the number of shells increases. So the distance, we know the atomic radius is the distance from the center to the valence shell. So while moving down the group, the number of shells increases, hence the atomic radius increases. And if we check alkali metals and alkaline earth metals are less denser compared to alkaline earth metals. Why it is happening? Because the alkaline earth metals is more tightly packed compared to alkali metals. Then electropositive character. We know both alkali metals and alkaline earth metals are electropositive in nature. The electropositive nature increases from beryllium to barium. This is also due to the atomic size and ionization energy. Why? Because while moving down the group, we know atomic size increases. So it's very easy to remove 2 electrons from the valence shell. So the electropositive nature increases down the group. And the ionization energy of these metals are higher compared to alkali metals. Because we know from moving left to right, the ionization energy decreases in a period. So alkali metals is come first, then alkaline earth metals. So the nuclear attraction on the valence shell of the alkaline earth metals more compared to alkali metals. Hence, they have high ionization energy compared to alkali metals. Electronegativity. These metals have very small electronegativity, that which decreases from beryllium to radium. Melting and boiling point. There is we cannot see a regular trend, uh, but the melting and boiling point is higher compared to alkali metals. This is because of two valence electrons, and they are strongly bonded in solid state than alkali metals. This is a trend in the boiling and melting point, and we have seen the coloration to the flame. Beryllium and magnesium do not give color to the flame. Conductivity. Alkali metals, they are also very good conductor of heat electricity, hence they are metals. We'll see the chemical properties. First one is reducing property. They are very strong reducing agents. For example, we are using so many reducing agents made up of alkaline earth metals. Why they are strong reducing agents? Why? Because they have 2 electrons in the valence shell, and due to large size they are comparatively easily oxidized. We know reducing agents are the which are undergo oxidation. So they are very strong reducing agents. Then reaction with oxygen. Alkaline earth metals react with oxygen to form oxides. This M representing alkaline earth metals. And the heavier metals, that is calcium, strontium, barium, are forms peroxides. Reaction with hydrogen. Calcium, strontium, barium react with hydrogen to give crystalline metal hydrides. For example, calcium hydride, barium hydride, etc. And these hydrides react with water which produce bases, that is dibasic. There are two OH minus ions, that's why it is known as dibasic. And if they react with water which form bases, and the basicity will increases as we go down the group. And if react with acid which give salts. Why the basicity increases down the group? Why? Because the ionic size increases in a group. As a result, the lattice enthalpy decreases. These all things we have already discussed in previous chapters. If they react with nitrogen, they form the metal nitrates. And if it is hydrolytes, the metal nitrates hydrolyze which give ammonia. And if react with halogens which give metal halides. Here you can see the metal hydride forms. And if we check the important compounds of alkaline earth metal, they form hydroxides, sulfates, carbonates, etc. Then their oxides are alkaline in nature, that is basic in nature, and while moving down the group, the basicity increases because the electropositive character increases. And their oxoacids. The acids which contain oxygen is known as oxoacids, and they also form oxoacids like carbonic acid, sulfuric acid, nitric acid, etc. Their salts react with bases, they form oxoacids. For example, sodium carbonate react with water, or hydrogen, which produce oxoacids. Similarly, we can prepare a lot of oxoacids from our alkaline earth metals. And their common uses. We know calcium exists in bones and salts. Magnesium in salts and helps metabolism. Barium can use in X-rays and it is in the digestive system. Radium is radioactive in used in cancer treatment, and they are very reactive. And we can use strontium in fireworks, magnesium and barium also in fireworks, and magnesium is used in airplanes, ladders, etc. And chlorophyll contains magnesium. Calcium found in marbles and necessary to strong bones, and it is also used in medical procedures, barium. And we'll see the similarities between alkali metals and alkaline earth metals. We know both are the group of in X block, both are electropositive, both have great chemical reactivity, both do not occur in the free state, they will form in the combined state. They are extracted by the electrolytic method of the salts, both are silvery, both are react with water to give metal hydroxide and hydride. The hydroxide of both give strong bases with water. We'll see dissimilarities. Alkali metals are soft, whereas alkaline earth metals are somehow hard. Each alkali metal has a single electron. In alkaline earth metals, it is 2 electrons. Here Ns1, here Ns2. They are having low melting point, whereas alkaline earth metals having relatively high melting point. Here the hydroxides are strongly basic, here less basic. Carbonates do not decompose, but their carbonates decompose to form oxide. Nitrate give corresponding nitrates and oxygen as products. Here it gives dioxides, oxygen as products. And here bicarbonates exist in solid form at room temperature. Bicarbonates exist in the solution from at room form at room temperature. These are the important nature of alkaline earth metals, and the chapter is over, and all other portion is deleted from this chapter. So it is very small chapter and it is very easy chapter. So study well. Thank you.